Well, ladies and gentlemen, today we're looking at common factors. Alright, so this is really the beginning of factoring. The previous two lessons were mainly a review or some preparation before we go more in depth with factoring. But before we move on to the specific lesson, which is common factors, I want to point out the following, something that I will be repeating a number of times in the future lessons. So let's take a look at this example, right? So far you've been familiar with these types of examples where they give you two binomials, right? You're given two binomials and you're asked to expand these, right? In other words, to multiply them. So what you do is you end up with this on the next line, right? And then you collect the like terms and you simplify this expression, right? So this is what we normally call expanding, right? Expanding, meaning you take two binomials and you multiply them, right? But factoring, it is as though the following, it is as though they give us the answer, right? They give us the final result, right? And the question will say factor, right? So that means we want to find out what two binomials, what two expressions, two or more expressions, but what two expressions cause this result, right? And of course our answer will be whatever we had at the beginning, right? 2x plus 1, right, times x minus 3, right? So in other words, factoring is the opposite of expansion, right? So expanding is when we multiply, when we expand two terms, when we multiply the binomials here and we end up with this result. Factoring would be going backwards from the result back to the question, right? So let me rewrite this, right? Factoring is the opposite of expanding. Alright? And this is essentially what we're doing when we're factoring. We're going backwards. We're doing the opposite of expansion. Alright? But first, before we start going more in depth with factoring trinomials, let's start looking at just common factoring, something that you guys are familiar with from previous grades, right? So let's start looking at some examples, okay? So common factors, let's start looking at this first example, right? 3x, let's just cover this for now, 3x plus 6y, right? So we want to factor out the largest the greatest common factor, right? So essentially what we're looking for is basically the largest factor that we can divide evenly into every term, right? Don't get confused with the lowest common factor. That's different. That's something that's the opposite, right? That's normally you do that when you're adding fractions that have a different denominator, so you're looking for the LCD or lowest common denominator or lowest common factor, but that's not the case here. Here we're looking for the GCF, for the greatest common factor, which once again is the largest factor that we can divide evenly into every term, right? So let's start looking at this expression here, 3x plus 6y, right? 3x plus 6y. Between these two terms, is there a common factor, right? Yes, 3, right? 3 divides evenly into 3, and then also 3 divides evenly into 6, so we can factor out the 3, right? So we start looking at the coefficients first. Let's look at the variables, right? We have x here, we have y here. Is there anything in common between these two? No, so that's it. So we factor out the 3. Let's open up the brackets. And what number do we need to multiply 3 in order to get 3x? Well, 3 times x will give us 3x. And then the signs as well, right? Positive, 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 okay. So what number do we need to multiply the 3 in order to get 6y? Well, let's start with the coefficients. 3 times 2, 6, right? So 3 times 2, 6. And how about for y? How do we get y? Well, simply multiply the y, right? So 3 times 2y will give us 6y, right? And that is our answer, right? Now remember also, when we factor out a number and we open up the brackets, we're expecting, if we started with two terms, we're expecting to end up with two terms inside this bracket, right? If you don't, then I would double check the answer, right? Let's look at another example. Now remember, essentially what I just explained to you guys right before about factoring being the opposite of expanding, right? Factoring being the opposite of expanding. In this example, we have just factored out this expression, right? We've represented this expression 3x plus 6y. We have represented this expression 3x plus 6y into a product of two expressions, right? Here a monomial times a binomial, right? In other words, we've actually gone backwards and found out what the question was, right? It is as though I've gave you that. In any case, we've just factored this, right? So these are just common simple factoring that we have seen before. Let's look at another example here. 17ac minus 34ad. Same idea. Same idea. Let's look at the coefficients first. Is there a common factor between these 17 and 34? Yes, let's factor out the 17, right? Let's look at the variables now. Any common factors? Well, there's an a here and there's an a here. So, okay, so a is present in both, right? Okay, and a divides evenly into these, right? How about we have c here and d there? Anything else that we can factor out? No, not really. So that's it. We're done. So let's find out now. Let's find out. 17a multiplied by what will give us 17ac? Well, we just have to multiply 17a times c to get 17ac, right? Now a negative, right? What number do we multiply 17a in order to get 34ad? Pardon, in order to get negative 34ad, right? Well, we have a positive here. If you want to get a negative result, then we have to multiply a positive times a negative in order to get a negative, okay? So we've taken care of the signs. Now, 17a multiplied by what in order to get 34ad? Well, 17 times 2, let's start with the coefficients. 17 times 2 gives us 34. A times what will give us a? Well, a times 1. So I don't need to write the 1 there, right? But a times 1 will give us 1, okay? And then 17a in order to get 34ad, right? Well, we just put the d here, right? So 17a times negative 2d will give us negative 34ad, right? So that's one way of double checking, right? Once you've finished factoring out the common factor, right? Try to expand this expression and see if you end up with that. If you end up with that, then you have properly factored out this expression. Right? Let's look at some other examples as well. Right? Let's look at this example. 16x squared y squared minus 24xy. Same idea, right? It's not always, of course, going to factor out nicely, but what's the greatest common factor between these two? Okay, we may be thinking 16, but okay, 16 divides evenly and very nicely into this one, but 24 divided by 16, no, not really. So it's not 16. Let's try the greatest common factor. Let's see another greatest common factor. So it's not 16. Well, these two numbers are obviously multiples of 8, so perhaps 8. Right? That will be the next one. So yes, 8 divides evenly into the 16 and to the 24. Great. Now let's look at the variables. There's an x present here and there's an x present here. However, there's an x squared present here and there's an x. Right? So this one has a power of 2. This one has a power of 1. Let's grab the one with the smallest power. That would be x. Right? Why? Because x to the power of 1 divides evenly into x squared, right? And same thing, let's grab the y here, right? Now you may be thinking, how come we didn't take the x squared? Well, let's see. If we took the x squared, this would have divided evenly and nicely into this one. It would have been 1, right? But how about x divided by x squared? That would have given us, you know, x to the power of negative 1, and that's not really helpful for our purposes here, right? We're trying to factor out x. We're trying to find the greatest common factor, right? So in this case, x would be the best one, right? All right, so we found the greatest common factor, and now same thing, 8xy multiplied by what in order to get 16, right? Well, let's start with the coefficients 8 times 2, right? And sorry, we want to get positive 16, so 8 times 2, 16, okay? X times what in order to get x squared? Remember, when we multiply expressions that have the same base but different exponents, we add the exponents, so times x, right? So x times x, x squared, and then y times y, y squared, right? So 8xy times 2xy will give us 16x squared y. Now, what number do we need to multiply the 8 in order to get negative 24, right? If the result of the multiplication is going to be negative when we already have positive here, so this has to be negative, right? So positive times negative, negative, right? 8 times what to get 24? 3, and then we have xy. So xy times what in order to get xy? Well, times 1. So we don't need to write the 1 there, and we simply leave it there, and we're done. All right. And here are some more examples, right? And I would like you to try these on your own, and we will take them up next time.